Alaikum, welcome to Nasir Soft. This is the third video of the data manipulation and cleaning tutorial series, and in this video we will talk about normalization and standardizations. So after watching this video you will able to learn the basic concept of normalization and standardization. So we will cover all these topic, and after watching this video not only theoretical you will learn this topic, but also you will know how you can implement the normalization and standardization in Python with practical example. So let's start. Normalize or standardize. Okay, so when we input some data set to a machine learning model that have different type of scalings, okay, sometime it might confuse the model. Okay, so therefore the normalization or standardization help model coverage faster and perform better. Okay, so let's understand it by example. For example, we have a data set, and inside this data set we have two columns. One columns is about the weight of elephants in tons. For example, 3 tons or 4 tons, or the average weight of an elephant is between 3 to 7 tons. Okay, and in another column we have the a butterfly length of a butterfly in millimeters. Okay, so when we train our model without scaling or without normalization, okay, we will see what is normalization later, then the weight overshadows the length in any mathematical computations, or it might confuse the models. So therefore we need to standardize, we need to standardize the data in some format. Okay, so for certain algorithm like knn, k-means or pca required features to have similar scales, data normalization or standardization ensure fair contribution of all features. Okay, so what is normalization? Normalization is very simple. Normalizations scale the data between 0 and 1. Okay, so basically this is used for when features have different ranges or unit, ensuring uniformity. The formula is very simple. Okay, so we will subtract the each data with the minimum value, then divide by x maximum minus maximum value minus minimum values. Okay, so this is called the normalization. So the normalization value is between 0 and 1. What is standardization? Standardization transform the data that to have a mean of 0 or a standard deviation of 1. Okay, so this is very important for algorithms that assume normally distributed features, for example linear regressions or pca. The formula is very simple. This is the z score. Basically z is equal to what data set, each data set minus overall data set mean divided by the standard deviations. Okay, so normalization basically rescale the data in 0 1, and standardization centers the data around a mean of 0 and standard deviation of 1. Okay, so the importance of standardization and normalization in data pre-processing is that it improves the model performance. It handle feature scale. Okay, it handles the feature that scale the difference. Okay, this chart basically explain when to normalize and when to standardize. Okay, so the purpose is align data to have same range of compatibility of normalization, and standardization is align data to common scale with equal variance of comparison. Okay, so you can pause the video and basically read all these point. Okay, so for example, on the start, with an example of elephant and butterflies in a same data set I told you. Okay, so in normalization means that we will rescale both weight tons and length fit between 0 and 1, and the standardization, if you apply the standardization on that example data, then it means that adjust both to their relative means and spread, making their scales comparative without rescaling to average. Okay, so let's understand normalization and standardization practically in Python. This is the Python implementation of normalization and standardizations. This code is the link of this code is mentioned in video description, so you can just call that specific link in order to download this notebook. Okay, so in order to implement the normalization, okay, from sklearn.preprocessing we import the min max scaler. For example, this is our sample data. Inside the data we have two features, the feature 1 and feature 2. The feature 1 data is this, and the feature 2 list of data is like this. Okay, so we can basically this is our data frame, and in through the normalization using the min max scalar, okay, so we call the min max scalar object and save it inside a variable scalar, and through that scalar dot fit transform of all our data frame, this will contains the creates the normalized data. Okay, so what is the normalization data? If we print out this here, you can see that the first value is 10, but now it's 0.00. The 20 is 0.25. So basically it converts the all feature data between 0 and 1. So this is called the normalization. Okay, so the standardization implementation in Python, from the same library sklearn or preprocessing, we import the standard scalar, and this standard scalar object, okay, when we transform the data here, you can see that each feature value is like -1 or 0 point something, and this is the standardization. Okay, so here let's implement it with a practical implementation. Okay, for example, we have a data like age, income, height of the people. Okay, so when we print out the data here, this is the age, this is the income. Here you can see that the age is 18, 22 to up to 70. The income is like the 20,000 to 10 lakhs something, and height is different. Okay, so before applying the normalization and standardization, if I visualize the data through the basically histogram, here you can see this data, the age is distribution according to like this 20 and 70. The income distribution is zero point 0.02 point something like this, and the height distribution is like this. Okay, so all of that is data have different scale. Okay, so if we apply the normalization on the data, it will convert the same scale between 0 and 1 to all these columns or data sets. So this is very important for a machine learning input. Okay, for example, after applying this in normalization through the min max scalar, if I again plot the histogram, here you can see that now the age is between zero point 0 and 1, the income is also between 0 1, and the height is also between 0 and 1. Before that, this is like 150 and 190. Here you can see that is between 0 and 1. So this is the uniform basically conversion of the scaling through the normalization. So let's apply the standardization on the original data. Okay, before applying the standardization, okay, so we can also call this standardization to z score. Okay, so before applying, if I histogram, I generate the histogram. Here you can see this after applying the standardization. Okay, so the histogram is like this, like this. Here you can see that how it converts the heights, income and distribution to a standardized after applying the standardized, how it looks like this. So this is the basic concept of normalization and standardization in machine learning. So I hope you have understood about this basic concept and the implementation of the normalization and standardization. The standardization is very helpful in outlier detections. Okay, in my outlier detection series of the previous video of this tutorial series, I explain the z score in more details, so you can also look this video link is also mentioned in video description. Don't forget to subscribe my channel for more informative videos. Stay blessed. Have a nice day.